Hi everyone, thanks for tuning in to ClearEdge's first YouTube live event. So hopefully first time, we've worked out all the kinks. I'm Dan Hood, the Chief Technology Officer at ClearEdge. With me is Tom Kolish, our Chief Architect. I'm sure most folks that are tuned in probably know a little bit about ClearEdge, but I thought I'd just give the high-level cap for those that maybe aren't as familiar. So ClearEdge, we're a small woman-owned small business defense contractor in Annapolis Junction, Maryland. Our primary focus, our core competencies are in the areas of data analytics, data science, large-scale compute, things like Kubernetes, and visualization thereof of that data, and across a bunch of different domains, Intel, cyber, open source, geospatial. So it's some breadth there in terms of the different areas. With that, I'm going to hand it over to Tom to talk about tonight's talk and tonight's talks, and all yours, Tom.
Oh, thank you, Dan. So, hi, welcome everyone to our first ever streaming. This is definitely new for me, new for Dan, and new for ClearEdge. So, why are we here today? I wanted to go over just a couple of the things that we're doing and what brought us here. First, just in general, ClearEdge has been recently involved and running new products or new technologies, specifically in the UI user development of UIs and geospatial area specifically. And we're really excited, and we wanted to show you some of the work and expertise that we've grown and that we've brought onto the team, and share that with basically now the world. For our agenda today, it's a little different, a little newer for us, and the format of this. Normally, we're not doing this live in front of the world. We're doing this live and in person, usually at events or venues. If some of you guys have been to Jailbreak before, we've done this there and had these kind of talks before. So given the current events, we decided to go for a live streaming environment. Today, we're having 4 talks covering a breadth of topics, from mainly focusing on the geospatial and UI development world. So these talks are a little different from how we normally would do them. Normally, in a lightning talk row, they're 5 minutes, they're auto-advancing slides. We did a little bit of hybrid model given the circumstances, and we kind of let the speakers be able to decide and speak on how they auto-increment those slides and how they actually talk. And we kind of range on time frame, anywhere from about 6 minutes to about 12, 13 minutes. So given that, I'd actually like to talk about how the speakers have previously recorded their tapes. They're not here with us. They're not behind us or hidden in any other room. They're actually live with us, though, in the chat room. So you can ask them a question at any time you want. Ask them any question. They're standing by to just answer anything you have from that standpoint. So, and finally, kind of wanted to go over another reason why we're here and what we're doing is ClearEdge has multiple open positions, specifically helping in this work and other work as well. We're looking for software developers, user experience, human factors engineers, DevOps engineers, system engineers. So if you see something you like here or something that's interesting, feel free to send us an email to careers@clearedgeit.com. So I think that's enough front-end work. I'll transition over to our first talk. So I actually work with, our first talk is by Andrew Sharp. I work closely with him currently right now on my current project. And he is absolutely an amazing developer, creating Geo UIs. He's been with ClearEdge for about 2 years and has over about 10 years of software development experience. He's developing enterprise applications using Leaftlet for the last 1.5 years, and he earned his Bachelor's of Science from the University of Kentucky. So here is Andrew.
I'm Andrew Sharp. I've worked at ClearEdge for a little over 2 years, maybe 2.5, give or take. And today I'm here to talk about viewing the world with Leaftlet.js. Quick run through what I'm going to talk about. We're going to review the Leaftlet Quick Start Guide. We're going to see how easy it is to add a map to your JavaScript app. Leaftlet is a JavaScript library. I should have said that before. Then we're going to learn a couple gotchas along the way and check out some cool features and plugins. So first, we have 2 really quick setup steps, and they are super easy. You literally copy and paste these includes your Leaftlet into the head of your document and into your leaflet.js file after the CSS. The order is important because the JS file uses your CSS file to work. After that, we create an object. You can see it's one line. The key components here are an ID that we'll use later. You can see that here. You'll see a center coordinates, which is basically where you want your map to be centered. That's just a lat long. And then your initial zoom level, I think it goes from 2 to 16. I think 13 is a pretty basic standard starting point. And then we tell our map what tile server to use. The tile server is what serves up the images that your map will use to plot on the grid. So it's you zoom to a level where it's a 3x3 grid. Each of those grid spots will be a tile that your tile server will give you. The way we do that is called the leaflet tile layer function. We give it a URL. Generally, it's in this format. The map box is just an example. There's tons out there. And then certain services will require an attribution in order to work. So, for instance, the map box requires this attribution variable, and then sometimes they require an access token as well. They're just strings, but kind of giving credit and all that stuff. And then what we do is we just add to the map, and then you'll see my map is the object we created before. And then essentially we find our car. It's in London. It's down there. So then let's add something else. Let's say, okay, we want to add a marker to our map. Well, it's another one-liner. We just create a marker object, we call leaflet.marker, tell it where, and then we add it to our map object again. And then boom, it's there. It's in London. So the full body of our app, just to kind of sum it all up, is right here. I know it's not formatted great, sorry. We create our div with a width and height. Height is very important. If you do not give a height, it will not work. Then we just create our map object, add our tile layer, add all the options to the map. It's legit 5 minutes of work, and it's pretty cool. So some gotchas, like I mentioned, you want a height on your map or it won't render. You will also want to pay attention to your tile server specs. Some of them are XYZ format, some of them are YXZ. Just pay attention to that. And then some tile servers also require a CRS value, and the wrong ones can make your map render weirdly, like upside down or 3 out of 10 tiles will load and stuff like that. And then the leaflet lat long, I forget versed, it's on standard, and I think it's long lat instead of lat long. It's not super intuitive, but there's enough documentation out there to catch it if you mess it up. There are also tons of plugins. Leaflet's got a super extensive library of plugins where you can draw shapes, edit the shapes that you've drawn, load in shapes from different formats like GeoJSON, KMZ, I believe, all kinds of stuff to allow user customization. Pretty much anything you might want to do on a map has probably been thought of and created into a Leaflet plugin. It even has a React wrapper library if you're in React, making the easy even easier. And then what if I'm in React? Well, you can see this is our JavaScript app from before I made the center position a variable just for conciseness, I think that's a word. So we set our view to the center, our tile layer, our marker that we added before, and then that just becomes, okay, we import React, obviously, import the few things that we're going to use from the React Leaflet plugin. Then, if you're familiar with React, and like Jess probably talked about, we will use all the individual components that we imported. So here's the map component, which is basically the same as l.map. Tile layer component, you can see you just give it a couple parameters like this. It's just a little more easier to read. And then marker, l.marker as well. We threw a little pop-up on this guy so that when you click it, a little window will pop up saying easily customizable. Yeah, and it's that easy. And then no ending, no more ending. Here are the sources if you want to see where I got all this stuff from. It's pretty simple, just Leaftlet.js, and all this stuff will pop up. And that's it. Any questions?
Thank you, Andrew. That was an amazing talk on Leaftlet.js, a core component of pretty much every GUI UI we currently develop right now. So it is definitely one of the first things I learned joining these projects. Was the depth and the actual pretty much cool feature set that Leaftlet.js gives you from a geospatial context. So if you have any questions for Andrew, please bring them up into the chat window. He's standing by waiting for you. Ask him any question about Leaflet. I'm sure he'll attempt to answer it and give you good advice. All right, so given that, I'm going to throw this over to Dan for talk number 2.
All right, so our second speaker this evening is Jessica Dixon. Jess has been with ClearEdge about a year and a half, I think, at this point. The last 8 months or so, really been focused using React specifically in the context of a geospatial team that we have. Jess earned her bachelor's in both math and computer science at Washington College, and she's going to give you a brief introduction on React. Jess?
Hi, I'm Jess Dixon, and I've been working at ClearEdge for just over a year and a half, and the past 9 months I've been doing front-end development using React. And I'm just going to give you a brief introduction to kind of what React is and the basic components. So what is React? React is an open source JavaScript library and framework for building user interfaces, and more specifically for single page applications. And it is actually the most used JavaScript front-end framework since 2016. And it was created by Facebook and released as an open source project in 2013. It was actually heavily influenced by another Facebook project, XHP. And a brief history of React. It kind of all started in 2011. Facebook was having issues with code maintenance, and as their developing team kind of grew, they were facing a lot of issues with cascading updates, so they kind of needed a solution for that. So they had an early prototype of what now became React. In 2012, as Facebook acquired Instagram, it became more of a push to make that project open source, and that came into fruition in 2013. And then a couple of years later, in 2015, it was becoming more stable, more heavily used. Redux was released, which is a JavaScript library for managing global state within React. React Native was released, and you started to see the first stable version of React developer tools in Chrome. So why use React? Mostly because it's easy. It's fast, scalable. You don't have to use any templates, and it combines markup with the corresponding logic, so it's easy to read and understand in your code. And they have client-side rendering, which makes it nice, and everything's component-based, which we'll talk about soon, which just makes everything organized and compartmentalized. So one cool thing about JavaScript is JSX, which is basically just a syntactic sugar in JavaScript, and it produces React elements, and within that you can use embedded JavaScript expressions and logic just within your code. So you can use it, so like here is an example, here are some examples. Here you have a JavaScript function just embedded in your code just within curly braces, and here's like a conditional in this example over here. And one nice thing about JSX is it also prevents injection attacks. So another cool thing about JavaScript is how they render their elements. React DOM is kind of manages how everything is rendered, but it only updates the DOM when absolutely necessary. So like when a state changes is when you'll see the DOM change, and over here is an example. You see all the code and just the time is changing when needed. So as I was saying earlier, React is component-based, which allows you to have concerns. You basically want to split up your UI into small, independent, and reusable pieces. And you do that with components. So in your app, you usually start with an app component, and then if you look at that, within your app component, you'll have other like subcomponents. You might have like a nav bar, a map per se, panels, and then within those you'll have other React components like buttons and just like small pieces that you can reuse, which makes it easier to update certain pieces of code without having everything be affected. And components will accept read-only inputs called props, and then it will return a React element. There's two different types of components. There's class-based components and functional components. I have up an example of each. Down here is an example of a class-based component. It basically just extends the React component class, and then in your render function, you will return the React element. Whereas with the functional component, which is seen above, that is like a JavaScript function, and then you will return your React element. And then when you go to call that component, you will use this format below, which is just using the component class name as your tag name and then passing through the props. It's very easy to use, and then you'll just call that in your like parent component. The class-based components are kind of being phased out because they don't have the ability to use React hooks, which we'll talk about a little bit later. So it's preferable to use the React functional components, but in most applications you'll still see a lot of the class-based components because the hooks are a newer thing. So now we're going to talk a little bit about state and those hooks that I mentioned earlier. State is very similar to props, except for they're completely controlled by the component. They're local to the component. Other components don't know about what's going on with a certain component state. And the state is handled differently between class and functional components, which is one of the reasons why class components are kind of phasing out. But with a class component, what you're going to do is you're going to establish your state using this .state in your constructor, and then you'll update it using this .setState throughout your code. And then to manage lifecycle, they have component did mount, component did update, and component will unmount, which are functions that will just be called when those different things happen. So like when your application first renders, when that component's being rendered, you'll have the component did mount function will run, and then when certain variables are changed, then you'll see the component did update function will run and make changes to your component. Functional components do this a little bit differently. They use hooks. The two most popular hooks are the state hook and the use effect hook. The state hook is how you create and manage your local state within your functional components, and basically with this you'll have your state name and then the name of your function that will change that state, and you'll just set it, initialize it here, and then you can use it throughout your component. With use effect, that's more like component did mount and component did update, where it will run basically when the component first renders, and then it will also run whenever like certain variables that are passed through that use effect hook are changed, then that function will be called again. And this is preferable to the class component ways, but it's a lot newer, so it was only introduced in 2019, so everything's kind of still transitioning into using this a lot more than they used to. So basically, summing up, React is an open source JavaScript framework for UIs. One cool thing about React is you could use it for your entire app or just one small part of it. It's not an all or nothing thing. So if you just want to use one React component in your application, you can, or you can go all out and do the whole thing. React only updates the DOM when necessary on state changes just for that single component, so you don't have constant re-rendering of your app. JSX is syntactic sugar that makes React easier to use and understand. And then the biggest thing is that React is component-based, so you can break your application down into small reusable pieces. You don't have to repeat yourself, and you have a separation of concerns. Here are my references. Any questions?
All right, thanks, Jess. I think Jess wins for the most memes in a deck, and the David S. Pumpkins reference there. But again, I want to remind folks, if you do have any questions, Jess and all of our speakers are in the chat this evening, so please feel free to ask the question. So with that, I'm going to hand it over to Tom. He has a special announcement for everybody watching the stream today before we dive into our last two speakers. So, Tom.
Thank you, Dan. Special announcement. Now, so if you made it this far, thank you. Also, we usually do drawings at these events. We're going to do that here too as well. So if you could and are interested in winning a prize, it is, I'll tell you the prize at the end. It's actually send an email with your name to careers@clearedgeit.com, and we'll put you into the drawing, and you have the chance to win, but a year of Disney Plus. So we'll send an email, we'll take a drawing, and we'll let you know if you've won. So given that, let's go on to talk number 3. So Rich Brady is someone who I have also had the pleasure of working closely with on my current project. And one of the awesome things about Rich is his love and desire to jump into new and emerging technologies. So he's actually going to talk about Quarkus, which is a new framework that we are starting to play with more in our new software development. So with that, I will leave it up to Rich to talk to you about it.
Hello, my name is Rich Brady, and I am a software engineer with ClearEdge. Today I'm going to do a quick tech talk on Quarkus, which is a technology that you may have heard of recently, but might not know anything about since it hasn't really been around for very long. What I'm hoping to achieve with this talk is address what Quarkus is, why does it even exist, and what does it look like in action? Well, if you pull up the front web page of Quarkus, you're immediately presented with some buzzwords. Supersonic subatomic Java. Okay, great, but what exactly does that mean, and how did we get here? I think to properly answer those questions, we need to give things a little context. Let's take a look at the general IT landscape and its evolution over the last few years. It wasn't that long ago that the dominant buzzword in IT was big data. At that time, Hadoop was on the scene, network latency was a tremendous constraint for moving around large data sets for processing, and so rather than move that data around, in order to compute it efficiently, the data was co-located and processed largely on premise, often many, many times. Fast forward a few years, and we still have large data sets, of course, but now the data is streamed with most processing happening on the fly. Network latency isn't quite the issue that it used to be, and organizations now have flexible storage options with multiple cloud sources to choose from. So today, I mean, really the IT landscape has evolved into a world of containers, microservices, and reactive programming. And this is where Kubernetes really comes into play. Basically, a container is the packed application with just the libraries it needs in order to run, and Kubernetes orchestrates and maintains these containers, making sure that they have the resources that they need. So how is the traditional Java Enterprise application and the JVM working out with the current microservices architecture? Interestingly, one of the Quarkus Red Hat developers, Sanegro Navarro, he gave an excellent presentation at QCon a few months ago, and he provides a few real-world use cases detailing the problems of running JVM applications on the cloud. During his talk, he illustrates some of these drawbacks, including them being cost prohibitive, they don't scale well, and really, you're most likely not going to achieve the higher levels of performance because it takes too long for the JVM in the application to warm up. Uh, Really, I highly recommend watching this presentation on infoq.com. It is free, and he goes much more in depth than the Cliff Notes version that I'm giving here. But Java has its own long and interesting evolution, particularly with context and dependency injection, which you can trace back all the way to the EJB 1.0 spec in 1997. It really wasn't until the last few years when Oracle silently was backing away from Java Enterprise, but luckily other enterprise vendors such as IBM and Red Hat picked it up and started a new initiative, initially released in 2016, called MicroProfile. And essentially, MicroProfile builds on top of Java Enterprise, but creates new specs and APIs, taking more of a code-first approach. The MicroProfile initiative really starts to bridge that gap to microservices and allows you to leverage the underlying Java Enterprise ecosystem and flexibly use their API. By itself, however, it's just still not quite enough when it comes to a complex enterprise application, and hence the need for a framework that will leverage the MicroProfile API as well as lend itself to Kubernetes orchestration. And for the trivia buff, Quarkus actually emerged from Java's CDI evolution in 2018 as a project called Shamrock and Protean, but then it was renamed to Quarkus in March of last year. With that, it also introduced a new dependency injection implementation called Quarkus Arc, and that incorporates most of the CDI 2.0 spec, but takes things a bit further by offering additional features such as the optional usage of certain annotations such as inject. Which brings us to the high-level view of Quarkus architecture. As you see, there's a Quarkus core component which relies and excuse me, with Quarkus, when essentially when an application is compiled down to its native I think during that InfoQ conference, Mr. Genevero was talking about, he had mentioned that even a small JVM service takes a half a gig of memory. So you multiply that by lots of microservices, and you're talking a lot of dollars. And this is also on Quarkus's website, but it's just an illustration of just how much. Let's go ahead and take a look at things. Okay, standpoint, it get Quarkus up. Quarkus website examples to get. So let's bring up a simple use, which is simply the services. Great thing, the prerequisites are we're using Maven. Let's use IntelliJ project, and this is probably a Quarkus via the Maven is happy. And pull it up in. Okay, so what does this give us out of the box? It's a pretty standard Maven project. You can see your POM file here with lists of dependencies. Obviously, in this case, we have our Quarkus REST easy, so we can actually create our REST endpoint, and it has a couple of testing dependencies. Looks like it's using REST assured for JUnit 5. Also, obviously, in the source folder, you can see we have our greeting resource, which will expose our hello endpoint, and we have a applications property file for the entire project. You just kind of put anything and everything in here that's a property, of course, and it also you some Docker file examples for using native and Java builds later on. So let's go ahead and see if we can get this thing going. And it is running. So I'm going to pull up a second terminal and go ahead and try a curl command for the endpoint, and we are good to go. So earlier I had mentioned Quarkus and its Arc dependency injection, which is relatively new, even though it builds on the CDI 2.0 API, but I thought it'd be good just to show real quick the @inject annotation in action here. So what I'm going to do is create a second service class, and we will import that into the a modified greeting resource class. And you can see here the @inject annotation. So let's see if we can get this installed. And we'll just replace it with the pre-built. Say view, open up greeting resource, and we're going to take you out and drop in the modified version. Since we're in dev mode, it should pick up the changes we just made on the fly. So let's give it a whirl here. And voila, good to go. So let's go ahead and package this guy and run it as a jar. Come back over here, we'll kill the service. And we can go ahead and simply package it by running the maven w command, package. Okay, so now if you look in the target directory, you can see our brand new snapshot jar, and which is a typical output, but also the runner jar, which we can go ahead and run via the command line. Grab that command. 'cause I can't remember things off the top of my head. And you can see how quickly that started up compared to when we were just running in dev mode. And let's try our services again. Yep, it's working. Also, you can pull this up on the browser. Let's do that here, if you want to do it that way. And everything looks like it's running. Obviously, that was a very simple REST microservice we created in Quarkus, but hopefully it gives you a sense of how easy the framework is to work with. I definitely encourage you to walk through the rest of the examples on the Quarkus site. They really get into building the native image as well as working with more of a reactive, some of the reactive APIs like Postgres and there's just so many. But at any rate, I think I am already run past my time limit, so I'm going to cut it here. I really appreciate you listening. Thank you.
Thank you, Rich. Quarkus is millisecond JVM spin up time and its cloud native ability, especially with Kubernetes. The adoption of Kubernetes lately has actually been extremely exciting for us on project, especially considering the amount of pipeline that Geo-UIs have inside them with developing geospatial applications. So it's pretty exciting technology we're working with here. So Rich is standing by in the chat room. If you guys have any questions to ask him, please feel free to do that. And I think I'll be throwing it over to Dan now for our final talk number 4. And this person's pretty amazing. Just to let you know, you might want to hit record on your screen, even though this is already being recorded. But just I'd say do it.
So to steal a little bit of Tom's thunder before I introduce the 4th speaker, some folks did let us know there was a little bit of audio hiccup. I just want to make folks aware that we'll post all the videos in their original form after the talk, in the coming day, within the next day or so, of all the speakers. So if you had any hiccups, you should be able to revisit them. So our last speaker, if you didn't guess, the last speaker of the evening is Tom. So Tom, I'll introduce Tom. Tom's been with ClearEdge about 10 years at this point. Really a breadth of large-scale application development. Currently leading one of our geospatial teams, dealing with very large amounts of data, both in terms of imagery and I'll call them points of interest on a map, right? So lots of data. Also has a background in large-scale distributed computing systems, ranging from Kubernetes, analytics, streaming analytics, and machine learning over very large-scale repositories. Tom earned his bachelor's in computer science from the University of Maryland. And a little bit of background on Tom's talk. Tom and I were talking, a couple weeks ago about what Tom, just brainstorming talk topics. And I think I'd thrown out, hey, have you seen the new Microsoft Flight Simulator? And somehow this turned into an excuse for Tom to buy Microsoft Flight Simulator 2020. I encouraged him to go buy an RTX 3090 to go with it. I don't know that he sprung for that, but it's on back order, isn't it, for everybody, right? So with that, I'll go ahead and we'll roll Tom's talk.
Hi, my name is Tom Coolish. I work at ClearEdge IT Solution. I'm the chief architect here. So today I'm actually bringing you a conversation or a topic that's kind of fun. We're going to talk about Microsoft Flight Simulator 2020, super exciting, and how it actually works with Geo and how it works with the world of Geo and the technology behind that. So first, let's start with some history. Microsoft Flight Simulator, I don't know if many of you know this, it is actually Microsoft's longest running product. It's not Office, which is 1990. It's not Windows, which was, I think, 85. It's not even Word, which was 83. Microsoft Flight Simulator is its longest running product. The first one actually on the left that you'll see there is Flight Simulator 1. It was actually built off of an Apple II product that was built in 1979, ported to IBM PC. Flight Simulator 4 is the one in the middle. That one was built in 89. It has dynamic scenery, some roads, some ground traffic, crazy for 89. And the small one over on the right is actually Flight Simulator X. I don't know if it was 10 or X. It was the latest one previous to this one, this generation's. So they had an actual SDK. You could go in there and actually edit things. It had ATCs, air traffic control, animations, and etc. So basically, 38 years later from number one, we are now here in this world for Flight Simulator. It's 2020, I believe the actual name of it is. So I'm actually first going to start you off with a little video of actual game footage. So this is a video of me flying this craft, virtually obviously. It's a Beechcraft Bonanza G36. We're starting off in the world around ClearEdge's headquarter building. So as you can see, if you're looking at this, you can see the trees, you can see the buildings, the parking lots, the roads. In games, usually these are painstakingly architected or builded or modeled on specific maps. I'll tell you exactly how it's being done, but I'm in a random place in the middle of Maryland, in which this is all being shown right now, and pretty accurate. You're actually flying past Route 32 right now, and I do know most of these roads. You're actually flying over some railroad tracks here. There's warehouses there. There's actual construction vehicle things. You're seeing this pretty amazingly in a good amount of detail, which I thought was pretty interesting. That actually 4 buildings. There's a post office there in the back. Been there before. And now we're about to pass ClearEdge here in your lower right, and going directly underneath it. You can feel it's an interestingly shaped building. It's kind of like a weird angle. I don't think game designers put when I got ClearEdge, I went like, we need to put that in the game. No. That is actually coming from some interesting places, which I'm going to show you about. As I'm taking a turn to go fly back over 32, and you can see ClearEdge's building right there. The parking lots look perfect. The building looks exactly how it is. It's almost spaced perfectly from 32 is where it usually is. So it's pretty cool in that sense. So my usual next question is how did they do this? And that was actually the first thing when playing this game. I'm like, how did you do this? So in some research, I first found out that the entire Earth is done. The complete Earth. You can go anywhere on the Earth and you're going to get as close to accurate representation of that. They're using Bing.com or Bing Maps, which I found interesting, just in general, Bing, and other sources of data. And then they're also using the cloud, because that's a lot of data on your local PC. So they had to use some sort of cloud to help with building some of the features like terrain, tree, grass, buildings, water. So they're using Azure, Microsoft Azure's cloud-based offering to do these things. So yes, I did say Bing because that's kind of interesting. Bing in itself, actually, what made me interested in this is that I didn't realize how much data was behind it. So there's 2 petabytes of graphic or map data that is helping generate these sources. So there's satellite imagery, the 3D geometry. So I actually had to look that one up. I didn't know what that was. It's actually an art or science. They call it an art and or science of extracting 3D information from photographs. Usually it takes your overlapping photographs of an object, a space, structure, and converting them into 2D and 3D models. Used actually a lot for your 3D printers. So they're taking that with doing also, Microsoft also got some flyovers of the world using LiDAR, which is a laser type radar, to increase some of the models that they have. They're throwing that into Azure and AI sources to analyze that data and create these 3D models for the game. And they're grabbing down to centimeter level of precision. And all of that done is kind of in an offline AI procedural generation function, not going into terrible detail there. Also, they did specifically pull in human artists and computer modelers to better define certain areas, specifically airports. And then they have they're streaming that data actually down to the game. That was interesting. The photo on your right is actually the top one, I believe, is an actual photo from Bing.com, and the bottom one is one that's in the game. So here's the pipeline. the thing is I think this is the pipeline. I am not a Microsoft employee, and I do not have understanding of the proprietary information. But from what I've read and some of the articles that I've driven into, I can see that they're basically pulling the data from the left, which is OpenStreetMaps, Bing Maps, LiDAR information, some more on-demand streaming things like current weather patterns, and also current live air traffic control, throwing that through the cloud. Using different types of AI. There's something called the Black Shark AI company, and they help create these like 3D maps. Their company do that, and then they're using also Azure's AI tools. That data is being funneled down into Microsoft Flight Simulator, and they specifically chose a game studio who specialized in graphic engines for huge virtual environments. They're actually out of Bordeaux and France. It doesn't seem like a bad place to be. Phil Spencer in February of 2020 actually made a comment when he said this. He said the competitors for Xbox, Phil Spencer works as the head of Xbox. He said the competitors' their interactive environment were no longer just the general Sonys and Nintendos, but the people they're competing against actually are Amazon and Google. So you could just see that the transition of moving away from just these console game systems is the main actual implementation of that. Right, it was actually back in 2009. Accidentally mistyped a building's height. Instead of writing 2 stories, he wrote 212 stories. No one saw that until someone was flying Microsoft Simulator, which Microsoft Flight Simulator, which was using this data, and they said that building is not in that city. It's just funny that like small open source data can be seen that you never would look at in any other fashion is showing up in there. So I thought it'd be fun to actually show you some actual real terrain through the game that's auto and procedurally generated 3D model. So this is me flying through DC, through the Wharf, which is a newly built downtown area with a bunch of boats, cool restaurants, hotels. You can see East Potomac Park up there. You can see the tidal basin. This is all being generated automatically. From here, just decided I was like, hey, I want to go to Cambridge, Maryland, which if you ever driven down Route 50, which is right below right there, to Ocean City, Maryland, you've driven through this city. And then from there, I was like, hey, I've always wanted to go to St. Michael's again, so let's fly by. So I decided to just drive down and fly over the city right there. Then I tried to take a step out and like, let's go somewhere else in the world, because you can go anywhere in the world. So I went to Germany, and I went to a random pad I think they actually built ships there. And then from there, I was going to Amsterdam. Never been there, so let's take a fly around. All of these areas are automatically generated. All of these parts of this city are these buildings are automatically generated and seen from above. And then I was thinking, I kind of really want to go to the beach. So let's take a flight down Siesta Key, Florida, and go see what that looks like from above. And from here, you can look and see the detail. You can see the spacing from the beach to actually the hotels. You can actually see, if you look close enough, you can see umbrellas that are generated from there. Enough city, I decided to actually also step back and say, let's go out into like the forest and look you can see the foliage, the tree coverage. That's Mount Rainier in Washington State. But you can fly around all of these places, which is pretty awesome. Another thing that people are doing, which I thought was kind of awesome, people are actually going storm chasing because they're pulling in real-time data, not only air traffic, but other types of data like weather. You can actually pull up the current weather and see a hurricane and go fly into it. You can be a storm chaser. So this is someone actually on the internet that went after and flew into Hurricane Laura. I flew into a couple ones, but I figured just to show you a picture. You probably didn't see enough video. Overall, the metrics are astounding to me, and that's kind of what I'm going to end on here. And this game is pretty awesome. That is coming from data driven from the cloud to your local machine. It has over 197 million square miles of land and water. There's 2 million cities and towns, 1.5 billion buildings that look really almost down to centimeter accuracy. 2 trillion trees, 37,000 real-world airports that you can fly into and land at. And from that, even if you turn up the detail level enough and your GPU can handle it, that you can see different species of birds, elephants, giraffe, bears, things that they've seen in pictures that are being modeled on the site. So overall, I believe this game is pretty amazing. It's using a combination of the cloud and Geo to create a pretty authentic, real-world, entire Earth set. Thank you very much. If you have any questions, feel free to use the chat. Sorry. You have to start over again. I totally forgot to put. That was my fault.
Sorry, we had I think a bit of a technical hiccup there, but I was telling Tom I think he had some stutter in his stream there, recording the Microsoft Flight Sim. I think he really needs to buy the 3090.
I really do.
So anyway, again, thanks Tom, all of our speakers. If you have questions, they're all standing by. If you have, are we off mute? Yep. Okay. With that, we will be posting all the videos afterwards, so they'll be available in their original form, high quality. So if there were any hiccups, again, you should be able to get them all there. Tom, you have any closing words?
No, first, everybody should probably buy Microsoft Flight Simulator 2020. It's pretty awesome. Secondly, figure out where the mute button is and know how to press it. Third, thank you guys all of you for attending. If you have any questions, you can throw them in the chat now, or even better, just add them to the comments at the bottom of here, and we'll be watching that, and we'll be able to respond to them. As Dan already said, this is already being recorded, so you can watch it whenever you would like in the future. And again, there is a drawing happening, or a drawing going to happen in the future. So if you would like to put your entry in there, please send an email to careers@clearedgeit.com, and just put in the subject line, either lightning talk or Tom's talking too much, whatever can get identified. Disney Plus is a good thing too as well. And then we'll let you know if you have won.
So just to sort of wrap up and close out, again, thanks for everybody that watched. Stay tuned for upcoming events, whether they're virtual or in person, I guess conditions permitting. I think now that we're streamers, we're obligated to tell people to smash that like button and ring the bell. But in all seriousness, follow us, on social media or our website. We post all of our events there pretty well in advance. So if you're interested in meeting any of tonight's speakers, or just learning more about ClearEdge, those are good opportunities to do so. So with that, wish everybody good evening. Thanks for tuning in.
Stay classy, Jessup, Maryland.